Hey everyone, welcome all to MAI course, and in this session we are going to cover this SL 5.3 topic which says derivative of fx equals ax to the power n, where we will start with n belonging to an integer. Okay, and what's the effect if that x to the power n is multiplied by a and we have any other polynomial function. Okay, so in this topic, we will see how to find these with the help of this formula as well as to find the derivative at a point using the technology GDC. Okay, so let's start with the problem. This formula says if you have to find the derivative of a x raised to the power n plus b x raised to the power m minus c x raised to the power, let's say, l. Okay, so I can directly use if fx is equal to ax to the power n, then its derivative is a n times x raised to the power n minus 1, where a is a constant number. So first of all, we can use the linear property which says you can distribute the derivative sign over the plus or minus, not for multiplication division. Okay, we have different rules for that. So first step is to rewrite it as d over dx of a times x raised to the power n. Then there was a plus sign. Then derivative of b times x raised to the power m. Then there was a negative, so keep it negative. D over dx of c x raised to the power l. Now use this that fx is equal to ax to the power n, then f prime is given by a n x raised to the power n minus 1 gives me this value as a n x raised to the power n minus 1, then plus sign as it is, b m times x raised to the power m minus 1 minus c l times x raised to the power l minus 1. Okay, that's how we calculate the derivative. Now let's start with a numerical problem which says differentiate y is equals to 4x raised to the power 2 minus 1 over 10x to the power negative 5 minus 3x plus 2. You can pause the video and try this question all by yourself as well. Okay. Now, in order to find the y prime or f prime x, or you can also call it dy over dx, all are same thing. Okay. So first we need to differentiate this 4x squared. So derivative of 4x squared. Then there is a negative sign and d over dx of 1 over 10 of x raised to the negative 5. Okay, this formula x to the power n equals derivative of x to the power n equals nx to the power n minus 1 works for any value of n, right? Any real number value of n, it works. So we have negative derivative of 3x, then plus the derivative of 2. Okay. Now, rate of change of 4x square will be 4 times 2x. We have to reduce one power of x, take that power outside. Negative 1/10 stays as it is. Then negative 5 x raised to the negative 6. Reduce one power of x. Similarly here, negative 3 as it is, x raised to the power what? 0, because you have to reduce one power. So x to the power 0, 1 minus 1 is 0. That gives you 1 at the end. Plus derivative of a constant number. Constant is not changing. So there is no rate of change for that. So its derivative is 0 for this part. Okay, always remember derivative of constant number is always 0. So hence the result says 8x minus, that gives minus minus becomes plus, 5 over 10 gives you 1 by 2. So x to the negative 6 by 2 minus 3 is the answer. Okay. Now, in the same way, if we are given a different problem, says given that fx equals to 4x squared minus 2x raised to the power minus 1, you have to find the f dash x. Also, you have to find the f dash when x equals 2. So you can also use your GDC to get this value directly. Okay. Okay. So let's find the f prime first. So f prime will be the derivative of this 4x squared comes out as 4 times 2x, which is 8x. Now negative as it is, 2 Then reduce one power of x. It is negative 1 already, so negative of x to the power negative 1 means negative 2. So I can write it as plus 2x to the negative 2. That's the answer for the f prime. First part. Now, in order to find the value of f prime at 2, simply substitute x equals to 2. So 2 times 8 times 2 plus 2 times 2 raised to the negative 2. Okay, simplify this and that's my answer. So it is 16 plus 2 over 4. Okay, 1 over 2. So 16 plus half. That is 33 by 2 or 16.5. Okay, that's the answer. You can also use your calculator to get the value of the derivative at a point. So for that, what you have to do is select the derivative at a point, dy over dx, then they asks for x value, substitute x equals to 2, and in place of this y, you can enter this 4x squared minus 2x to the power minus 1. Directly you will get 16.5 as your answer from there. Next, here we have to find the derivatives for the following functions. Fx is equal to 3x squared times 4 minus x to the power 4. So in this case, you cannot differentiate 3x squared separately and this separately. As I said in the beginning, linear property says if they are separated by plus or minus, then only you can distribute that derivative sign, but not in this case. Okay, so for these type of problems, first you need to simplify your expression, because you can differentiate x raised to the power n, which is n times x raised to the n minus 1, but not in multiplication, right? So first let's simplify this expression. So we can say fx will be equals to, distribute this 3x square to each term in the bracket, gives me 3 times 3x squared times 4. So 12x squared minus then 3x squared x to the power 4. So x squared times x to the power 4 will become x to the power 6. So I can rewrite it as negative 3x to the 6. Now it is in that standard form. So from here I can find the f prime. Okay, so for that, this one. So 2 comes out, 12 times 2, you can directly write now. 24 x raised to the power 1. Then take this 6 outside, which becomes 3 times 6 becomes negative, negative was already there. So negative 18 x raised to the power, reduce one power 5 is the answer. Okay, so sometimes we need to simplify expression, right? Convert it again. We have fx equals 1 minus, no need to take LCM. Simplify it, 1 minus 3 over 2 and rewrite that x to the power 4 as here it will become x to the power negative 4 in the numerator. Now that's your function. So now you can apply the derivative rules. The derivative of a constant number is 0. So 0 minus 3 half as it is. Reduce 1 power of x. Take it outside. So negative 4 times x to the negative 5. And that's my answer, which is 12, or you can cut it 2. So it will become 6. So it is 6 times x raised to the negative 5. The answer. Okay. So now let's move to the next problem. What it says. Here 4x square minus 3x plus 1 over 5x. Again, you cannot distribute the derivative sign to numerator and denominator. There are rules. Quotient rule. Yes, we can use quotient rule. But in this session, we are going to convert it in the simplified form, and then we have to differentiate it. I'm not going to use quotient rule for this problem. For A part, we can use product rule also. For C part, we can use quotient rule also, but you will learn these in MAIHL. Okay. So now here, let's rewrite the expression fx equals 4x square over 5x. Distribute the denominator. Okay. So negative 3x over 5x plus 1 over 5x. Simplify it further. We get 4 by 5 x only minus 3/5 plus 1 over 5 times x to the negative 1. Now it is the expression fx. Now we can differentiate this by f prime x equals, take term by term, first this one, 4/5 of x. 4 by 5 x, reduce one power, it will become 0. So we can simply write 1 only. Now the derivative of 3/5, constant number, its derivative is 0. Now for this 1/5 of x to the power negative 1, it is negative 1 over 5 x raised to the negative 2, and hence the answer. Okay, so my answer comes out as 4 by 5 minus 1 by 5 x square. Okay, so in this way you can solve these problems. So let's solve a real life based problem or application based problem on this derivative using the same rule. In economics, the marginal cost is the cost of producing one more unit. This point is very important. Marginal cost is the cost of producing one more unit. It can be approximated by taking the gradient of the cost curve. So in order to find the marginal cost, we will take the derivative. A company produces motorbike helmets and the daily cost function can be modeled by following. So this function gives us cost function for X number of helmets produced on a particular day. Okay. So X is the number of helmets produced and C is the cost in US dollars. First part says write down the daily cost to the company if no helmet are produced. What that means? It means they want us to find the value of cost when X equals 0. So can I say it is C of 0? Or you can also call it C of X, cost X when X equals 0. So simply substitute X equals to 0 here and get your answer. That gives you what? 600 plus 0 minus 0, directly 600 is the answer. Okay. Now the second part. Find an expression for the marginal cost. What is marginal cost? C prime x. You know it is calculated by taking the gradient of the cost function. So now for that we are looking for the derivative of this. So simply take the derivative only. C prime x. Term by term take the derivatives. For this the derivative is 0. For this the derivative is 7 only. For this the derivative comes out as negative as it is. So 0.0001 multiplied by 3 times x raised to the power, reduce one power 2. Okay, so that will be our derivative now. Final answer is for the B part. Now C part. Find the marginal cost if the first part says 80 helmets are produced. So for this you can also use your GDC, right? Or you can substitute X as 20 in this expression. So for this part they want us to find the value of C of 20, C prime 20, and 80 helmets produced means C prime at 80. Okay. Now we can simply find these. Next part, state the unit of marginal cost. What is marginal cost? It is C prime x, which is the derivative of cost function with respect to number of helmets. So can I say the marginal cost have the units, number of helmets is represented by x, cost is in US dollar, so US dollar or the cost per helmet produced, right? So now the answers are as follows. As I said, directly substitution. C of 0 is the answer to the first part. C prime 0, C prime x, sorry, is the answer to the second part, which we already calculated as 7 minus 0.001 times 3 times x squared. And the last, this one was the value C prime 20, and this is C prime of 80. Marginal cost is what? US dollars per helmet. That's the answer. Okay. So that's it for today. And now we have revised all these, how to find the derivative of x raised to the power n, rearrange the terms and find the derivative. Okay. So I'm giving a homework question to you. Try this question all by yourself and I'll see you all in the next session. Thank you for watching this. See you in the next part. Keep watching, keep learning.